So today topic face to face from unit 5 thermodynamics and statistical mechanics. So the first question, then face to face is a space in which each point represents the correct option. C is correct. Okay, then complete state of a system, that is both position and momentum. Okay, most important for face to face. If it is in cases face to face badila, then ordinary face in ketirunda to choose only position. Okay, then ordinary space now only position coordinate. In face to face we have to choose complete state of a system, both position and momentum. Okay, most important. For a single particle moving in one direction, the face to face most important. For one dimensional, position x, then momentum px. So this is two dimensional. The correct option is B. Okay, for a system of n particle moving in three dimensional, the face to face, so n particle moves in three dimensional. About three dimensional, how to say, three position coordinate, and three momentum coordinates. Appo total 6 for n particle. Appo 6n. So the correct option C is correct. Okay, so most important. So problem oriented are a question varum. Okay, so the coordinates used in face to face are generally, so before the question itself we discuss position and momentum. Most important, you have to remember while asking instead of face to face ordinary space data only position. In face to face both position and momentum. Okay, so the most important question. Sometimes it makes mistakes. Okay, a point in face to face is called, it's a basic question, that is state of the system. Then state of the system, it is represented by every point. So option A is correct. Okay, so next one is problem. Then determine the dimension of face to face is 4 particle moving in 3 dimensional. Okay, so there is a 4 particles moving in 3 dimensional particles. So before cases number paathirupom. So for n particles, in 3 dimensional 6n. Upper 6n, which is equal to, what is that? Here 4 particle, above n is equal to 4. Okay, just we have to multiply, then 6 into 4, that is 24. So the correct option, where is 24? Option C is correct. Okay, you have to understand. So then before cases you see that for n particle in 3 dimensional 6n. So the same formula we have to use in these cases. About 1 particle in 3 dimensional we have to get 6n, where n is the number of the particle. Here we given 4 particles. Just we have to put n for 4, then we have to multiply, then we have to get 24. Okay, so then similar for question number 7, a system has face to face dimension 30, important. Here find the number of the particle in 3 dimension. Okay, here number of particles கேட்குறாங்க. ஓகே, அப்போ ஃபேஸ் ஃபேஸ் டைமென்ஷன் கொடுத்தாச்சு. அப்போ ஃபேஸ் ஃபேஸ் dimension which is equal to 30. Okay, appo here moving in 3 dimensional, appo 3 dimensional what is there, dimension is 3n. Okay, so this is the most important. For 3n dimension la we have to see that what is that, 6n. Okay, appo we have to put 6n which is equal to 30, then n is equal to 30 by 6, then we have to get 5. Option B is correct. Okay, I hope you have to understand. Okay, so most important. So sometimes maybe question like this. Okay, so just then face face dimension 30 கொடுத்துட்டாங்க. So the number of particle moving in 3n dimension. அப்போ 3n dimension, so already நம்ம பார்த்துருக்கோம். For here we have to take it as a here then cn. Okay, 6n, don't confuse it. Okay, we have to take it as a 6n. Okay, so already we have to solve this one from this question. Okay, 6n. So here just to substitute, then we have to get the answer 5. Okay, so the next one, in classical mechanics the evaluation of a system in phase to phase, the correct option is in Hamiltonian equation, most important. Okay, so then question number 9, the phase tangentially in phase phase represent. So phase tangentially is most important word. Okay, so which one is correct option? Then phase phase tangentially only for time evaluation of a system, so option B is correct. Okay, so question number 10, the Lewis theorem is associated with conservation of. So most important, கண்டிப்பாக ஒரு கொஷின் வந்துடும். ஓகேவா, ஆர் மேபி டைரக்ட் ஆர் இன்டைரக்ட். ஓகே, so the Lewis theorem that should be conservation of phase phase density. Option C is correct. Okay, then most important. Okay, so அப்போ பேசிக்காக ஃபேஸ் ஃபேஸ்னால் என்னன்னு தெரியணும். ஸோ ஃபேஸ் ஃபேஸ்னால் என்னது, தென் எவ்ரி ஸ்டேட் ஆஃப் ஏ சிஸ்டம் இஸ் ரெப்ரசன்டட் பை சிங்கிள் ஸ்டேட். நெக்ஸ்ட்டு ஒரு சிஸ்டம் கொடுத்துட்டு அதோட ஃபேஸ் ஃபேஸ் டைமென்ஷன் கேட்பாங்க. ஓகே, ஃபார் எக்ஸாம்பிள் தென் most important. Okay, then particle in one dimension na, appo what is the phase phase dimension, 2. If it is particle in 2 dimension na, what is that, here 2 momentum and 2 position above, then we have to get 4. Okay, so this is 2 particle, that is important. 2 particle, here 1 particle. So if it cases then 2 particle in 3 dimension, then how many, we know that 6n. Up here 2 particle, up 6 into 2 we have to 12, up 12 phase is dimension. So most important. Okay, you have to remember the same one, we have to solve those 2 problems. Okay, so problem கேட்டால் இது மாதிரி தான் கேட்கலாம் ஃபேஸ் டு ஃபேஸ்லேருந்து. ஸோ மோஸ்ட் இம்பார்ட்டன்ட் அண்ட் பேசிக்ஸ் திங்ஸ். ஓகே, ஸோ யூ ஹவ் டு ரிமெம்பர் தோஸ் பாயிண்ட். ஓகே, தென் ஃபேஸ் டு ஃபேஸ்னா ஃபேஸ் டு ஃபேஸ் என்னன்னு தெரியணும், தென் ஃபேஸ் டேஞ்செண்டரி, தென் லூவிஸ் தியரம், அண்ட் ஹவு டு ஃபைண்ட் அவுட் த phase phase dimension for the given system. If the particle may be in 1 dimension or 2 dimensional, then particle different கேட்கலாம். If 2 particle in 3 dimensional, then 2 particle in 2 dimensional, then 1 particle in 1 dimension. the question may be like this. Okay, so these are all the most important. You have to concentrate those question. Okay, so if you take some of the previous question paper, those questions may be like this. Okay, so then we discuss next topic in next video. Okay, thank you.